We're beginning chapter 4, which is over quadrilaterals. So we're going to begin with pre-chapter 4, skills and practice, just kind of look over some algebra things before we begin. Properties of parallelograms, ways to prove that a quadrilateral is a parallelogram, Unit 4.3. Theorems involving parallel lines, Unit 4. Unit 5 is special parallelograms, rectangles, rhombuses, and squares. Objective 6, or Unit 6, is a special unit just for trapezoids, another uh, type of quadrilateral that's not a parallelogram. Then we have the odd answer solutions for Chapter 4 and the study guide for Chapter 4. So we will do the pre-Chapter 4 skills and practice, a little bit of review of algebra. What we're going to be looking at in this pre-Chapter 4 skills and practice is factoring quadratics. Factoring quadratics and the difference between two squares and a binomial square and some of those things. On page 200 of the Algebra 1 text, we look at multiplying binomials. Some teachers, in fact, I think most teachers today, use what's called the FOIL method, F-O-I-L, FOIL method of multiplying two binomials. I don't use that method. I just use plain old distributive property. Because when you use distributive property, you can see the steps of the AC method backwards a little bit better, and I'm just kind of a order operations guy. So the order of operations in the algebra textbook is page 33. Multiplying binomials is page 200. The difference between two squares is page 204, and binomial squares is page 206. This is chapter 7 of my Algebra 1 text. You're going to need some of that to solve with, and then the AC method of factoring is from page 213 to page 215, AAA, in the Algebra 1 text. The quadratic formula, which is at the bottom of this practice, is page 221, I believe, of the Algebra 1 text. So it might do you good there. If you need more examples, or if you'd like a paragraph that explains it or something, then you can go there and look at those pages. Okay. What we have here on numbers 1, 2, and 3 is the difference between two squares. Difference meaning subtract between two square numbers. Now, the first situation, we have x squared and y squared. And so it's the difference between those two items squared. Now, we learned in algebra that the difference between two squares is a result of multiplying what we call binomial conjugates. Binomial conjugates. Again, you can find this in the Algebra 1 text on page 204. Binomial conjugates are the two items that we see being squared, the x and the y. Except one of the binomials has a plus and the other binomial has a minus. Those are called binomial conjugates. The result of multiplying binomial conjugates is the difference between two squares. Therefore, if we see the difference between two squares, we can factor that into the binomial conjugates. We should be able to see the 9 right here as 3 squared. Thinking of the 9 as 3 squared, then what we see is the difference between two squares, the difference between x squared and 3 squared. The difference between two squares factors into binomial conjugates, which is the two items that were being squared, one with a plus and one with a minus. So x squared minus 9 would factor into the binomial conjugates x plus 3, x minus 3. On page 171, we learned about distributive properties summed up in the Algebra 1 text. And on page 170, we talked about raising powers to powers. If we had 2x quantity squared, then what we have is an exponent happening to a parenthesis. We said if something's crammed on a parenthesis, you check for distributive property, and we said that an exponent would distribute on the multiplication. So what we have here is 2 to the first raised to the second, x to the first raised to the second, which is raising powers to powers. When you raise a power to a power, you multiply the exponents. 2 to the 1 times 2 is 2 to the second. X to the 1 times 2 is x to the second. And so the result is 4x squared. So we can see that 4x squared is the same as 2x quantity squared. Over here, top left, this 4x squared then is the same as 2x quantity squared. In the same way, the 25y squared is 5y quantity squared, again because of raising powers to powers, page 170 of my algebra text, and distributive property summed up, page 171. And so then we'll recognize this as the difference between these two items squared. The difference between two squares factors into binomial conjugates. The binomial conjugates are the two items that were being squared. I'm going to try to write that neater, having trouble getting it in there. 2x and 5y, 2x and 5y, but one with a plus and one with a minus. Again, the difference between two squares factors into binomial conjugates. Any questions on the first three? Again, you can go back into the algebra text to get some of this review if you need more review. On numbers 4 through 6, we're going to factor the quadratics using the AC method. Now, the AC method of factoring is on page 213 of the algebra text. If you follow along there, there's more examples on page 215, A, double A, triple A. And so you can see some good examples in there. You really should study that whole section to remind yourself of how to factor. You're going to need this to solve some of the problems in this chapter. You're also going to need it as you move on into Algebra 2 and college algebra. So I'm going to shift this up just to clean the board up a bit. So we will be using the AC method of factoring from page 213 of the algebra text. Now, the AC method has several steps. Step 1 says to multiply the A times the C. Now, we need to know what those are. Standard form of a quadratic is ax squared plus bx plus c is equal to 0. You'll find that on page 194 of the Algebra 1 text. So, if it is of the form ax plus ax squared plus bx plus c, and right now we haven't really set it equal to 0. We'll do that down here when we're actually trying to solve. Here we're just trying to learn how to factor because it's not equal to 0, but we're still going to try to use the AC method here. Now, the A is the coefficient of x squared, which is understood 1 by multiplicative identity. That's on page 29 of the algebra text. The B of the quadratic is 5, and the C of the quadratic is 6. Using the AC method, we would multiply the A times the C, which is a 1 times 6, and get 6. And what I tried to teach my students there is to think about what the sign of the AC answer was, and we're going to focus on the fact that the sign of the AC answer is positive. Step 2 says find all the factors of the AC answer. So we want all the factors of 6. Well, the way you can get a 6 is either a 1 times 6. I'm going to leave the times off, excuse me. 1 times 6 or 2 times 3. Now this is where I start having my students focus on their sign rules. Because right now we're looking at factors, things you can multiply to get a 6. And so we're going to say our multiplication sign rules. When you multiply with blank signs, the answer is positive. Well, the answer is when you multiply with sign, the answer is positive. Sign rules are on page 18 of the algebra text. If you don't have those memorized word for word, it would be a good time to do that. So we know they got to be the same sign. Now step 3 says pick the pair that add to give you the B using sign rules. And the B is a 5, and we want to focus on its sign, which is positive. Now we've got ourselves set up for sign rules. So we're going to say our addition sign rules. When you add or subtract with the same sign, this is where you have to quote page 18, add and take the common sign over here to the B, which needs to be positive. When you add or subtract with the same sign, page 18 says you add and take the common sign, which needs to be the sign of B, which is positive. So these need to be the same sign and positive. So it's a positive 1, positive 6, positive 2, positive 3. Okay? And those dots are just to focus on those things. I hope that wasn't a distraction. I probably shouldn't have put them. Just trying to get you to see where I was aiming at. So which pair do add up to B? Well, the 2 and the 3. 2 plus 3 is 5. So we pick the pair that add to give us B using sign rules. Now, I'm going to do a little cleaning up here, just so we'll have some room to work and really focus on what we're doing. Pick the pair that add to give you B using sign rules. And then the next step says, step 4, split the middle term into those two pieces. We're going to change that 5x into 2x plus 3x. We got to have the x on there, 2x plus 3x. So we bring down the x squared plus 2x plus 3x. We bring down the plus 6. And so now we have x squared plus 2x plus 3x plus 6. Step 5 says factor the left pair and factor the right pair. How to factor the left pair and the right pair is at the top of page 213. It shows you there how to find the greatest common factor, which is also on page 5 of the algebra text. We're going to factor out the greatest common factor between x squared and 2x, which would be an x. Well, how did we get that for those that don't know? Well, you would write out all the factors of x squared, which are x times x. And you would write out the factors of 2x, which are 2 times x. And then you would find the common factors. You would take one each of all the common factors and multiply, and that would be the greatest common factor. There was only one common factor, so that's what we pull out, an x. So then we think, x times what will give us x squared? Well, x. When you multiply with like bases, you add the exponents. X times what is 2x? Well, 2, and it's positive, and so we have x times x plus 2. Out of the right pair, We have a 3x, which is a 3 times x. We have a 6, which if we do the prime factorization, gives us a 2 times 3. So they have a common factor of 3. There's only one, so that's what we factor out. So then we think 3 times what is 3x, x. 3 times what is 6, 2. So we get a x plus 2. Now, we're hoping for a common binomial. If we do not get a common binomial, either it doesn't factor or we made a mistake. But we did get a common binomial, and so now we will move to the next step. The next step says write it as the product of two binomials. The first binomial is going to be that common binomial x plus 2. And the second binomial is the pieces x and positive 3. And so we factored the quadratic into two binomials that would produce it. Any questions on number 4? So the answer to number 4, x plus 2 times x plus 3. Now, we do want to call attention to this. If A is 1, then it may not be necessary to go through this whole AC multiplying process to know how to split it. In fact, we could go right straight to the answers by thinking this way. Now, this is only if A is equal to 1. If A is equal to 1, we want to think, what can I multiply to get 6 and add to get 5? What can I multiply to get 6 and add to get 5? And the thing I can multiply to get 6 and add to get 5 is a 2 and a 3. And we can take the 2 and stick it there, and the 3 and stick it there, and we could skip all that stuff in the middle. Now, again, you can only skip all of that stuff in the middle if A is 1. And you do that again by thinking, what can I multiply to get 6 and add to get 5? Okay? Which was a 2 and a 3. All right. Let's look at the next one. 2x plus 6x minus 8. Now, this is not set equal to 0, and we do have to factor, so we can't divide by 2 and create a 1. It's not a 1, so we can't do that shortcut. We can't say, what can I multiply to get negative 8 and add to get negative 6. We cannot say that because A is not 1, so we can't go through that shortcut routine. We have to use the full AC method. So we're going to start running that drill. We're going to take the A times the C. The A was 2 and the C was negative 8. And when we multiply, we get negative 16. And we want to focus on the fact that the sign of that answer was negative. Excuse me. That was weird. We always want to focus on the signs. Now, step 2 says find all the factors of the AC answer. Now, we're not going to worry about that negative yet. We'll take care of that in a minute. We're just going to say 1 times 16 is 16, and 2 times 8 is 16, and 4 times 4 is 16. So that's all the factors of 16. For just a second there, we don't focus on that sign. Now, we're going to think, though, when you multiply, we're finding factors. When you multiply with blank signs, the answer is negative. Well, when you multiply with different signs, that tells me that these factors have to be different signs. I just don't know whether to make the small one the negative or the big one yet. So we got to kind of leave it hanging. We know they're different signs, but we don't know if it's the large one that's the negative or the small one that's the negative. Now we go to step 3, which says pick the pair that add to give you B using sign rules. Pick the pair that add to give you B. Using sign rules. Now is where we have to be able to quote the sign rules from page 18. So we say, watch how this works. We want to pick the pair that add to give us B. B is equal to 6, and it's positive. So here's our sign rules. When you add or subtract with different signs. Now we go to page 18 in our mind. When you add or subtract with different signs, you subtract and take the larger sign, which needs to be the sign of B, which is positive, larger sign positive. That means the smaller signs are negative. They say we got that? And we want the pair that gives us a 6, and that would be a -2 and a +8. So now we move to step 4, which is to split the middle term into those two pieces. So we're going to change that 6x into a -2x plus 8x, -2x plus 8x. And we're going to let that negative be indicated with a minus sign, and that positive be indicated with a plus sign, and there's still a -8 at the end. So we split the middle term 6x into those two pieces. Step 4. Now again, we're using the AC method on page 213 of the Algebra 1 text. Step 5 there says factor the left pair and factor the right pair. On the top of page 213 is where it shows us how to find greatest common factors. Now let's look at this again. If we take that 2x squared, its factors would be 2 times x times x. If we take -2x, we're going to pull off the -1 and then have times a 2 times an x. We find the common factors, a 2 and an x. We multiply one each of the common factors, and that product is the greatest common factor, which is what we pull out. We can see pretty clearly there that between the 8x and the -8, we would pull out 8 from that pair. So on the left pair, we say 2x times what is 2x squared, and it's an x. On the right, on the other side there, 2x times what is -2x, and it's a -1. We already have 2x, we just need to change its sign. Over here on the right, 8 times what is 8x, and it's an x. We already had the 8. On the right, 8 times what is -8, and it's a -1 because we just needed to change the sign. Again, we're hoping for a common binomial. And we have one. We have a common binomial of x minus 1. If we do not have a common binomial, either it's not factorable or we made a mistake in trying to factor it. Step 6 says write it as the product of two binomials, and that first binomial is going to be the common binomial x minus 1. The second binomial will be the pieces outside, 2x from the first part and an 8 from the second part, and that 8 from the second part is positive, and so we put a plus in front of it. So we have x minus 1 times 2x plus 8. We have successfully factored the quadratic. Now, from this pair, there's a common factor. And so we can't leave it like that because that's not in simplest form. So from that, we could pull out a common factor 2 and have 2 times what is 2xx, and 2 times what is 8, 4. And then we'd have to put that other factor back with it, And so it actually factors into three pieces, 2 times x plus 4 times x minus 1. Any questions on that? We could have, if we want to use that little shortcut method, we could have said, well, let's just go ahead and take that common factor out to begin with. Let's just take out that 2. We can't divide by 2 because it's not an equation, but we could factor out a 2, and we could have 2 times x squared plus 3x minus 4. Now, that gives us an a of 1, and so then we could use our shortcut and say, what can I multiply to get negative 4 and add to get 3? And the answer would be a positive 4 and a negative 1. You multiply those, you get negative 4. You add those, you get negative 3. So we could put the 4 in one of these and the negative 1 in the other one, and we would have it factored. And that was a whole lot easier than doing that entire AC method stuff. You may say, well, why do we keep doing that? Because the first two, we didn't even have to do it. Well, we want to learn the AC method of factoring, but then you do need to recognize that if A is 1, there's an easier way to think through it. And if there's a common factor, you could factor out that common factor to begin with and maybe make it simpler on yourself. Any questions so far? Okay. Now, what's going to happen? Well, we'll just go ahead and talk about number 6. On page 206, page 206 of the algebra text is a lesson called the square of a binomial. And there's a little formula that says a plus b quantity squared is equal to a squared plus 2ab plus b squared. Sometimes I don't get to spend as much time on some of this as I would like to in Algebra 1. But what we're going to learn there as we look at a binomial squared, and as you talk about that, is there again, if a is 1 and half of the middle term squared, just a second, I need to pause here, my overhead went off. So if a is 1 and half of the b value squared is equal to the c value, half of 8 is 4, quantity squared is 16, then what you have is a perfect square binomial, which means you have a binomial times itself. And that binomial is going to be x plus whatever half of the middle term was, which was a 4. Okay? Now we could use the AC method there again, but we also had it in the form of a perfect square trinomial, which factors into a binomial square. Again, the rule is to be a binomial square, a has to be equal to 1, and the value of c needs to be 1/2 the value of b quantity squared. If a is 1 and c is equal to 1/2 of b squared, then it's going to factor into the binomial square x plus whatever half of b was, quantity squared. If a is 1 and c is half of b squared, then it factors into x plus half of b squared. So let's shortcut this thing. Is A 1? Yes. Is C half of B squared? Yes. A is 1. C is half of B squared. Therefore, it's a perfect square trinomial. Therefore, it factors into X plus whatever half of B was squared. Okay? Just some reminders from Algebra 1 in factoring. All right? Again, that's the lesson on page 206 of the Algebra 1 text. Now, number 7 and 8 say solve for X by factoring first. On page 214 of the algebra text, it actually talked about if you have two factors that have a product of 0, then either one or the other or both of those factors is 0. So then we set each of the two factors equal to 0 and solve. Let's talk about that. And let's talk about what a solution to a quadratic even is. Let's talk about what the graph of a quadratic looks like. Just a reminder that the graph of a quadratic is a U. It's going to dip down and come back up possibly. In Algebra 1, most of them did that. In Algebra 2, you'll have square radical roots, irrational roots, and imaginary roots. But remember that we talked about the solutions to a quadratic were the x-intercepts of the quadratic. They were the values of x that would make y be equal to 0. And if y is equal to 0, you didn't go up or down, so you must be setting on the x-axis. Therefore, they are the x-intercepts of the quadratic. And so when we solve, one way we could do it is to graph it and look for those intercepts. We also could solve by factoring. Now, here's a situation where a is 1, and so we want to factor the quadratic. And so we can say, what can you multiply to get 12, but add to get 7? Well, it's a 3 and a 4. And so it's going to factor into x plus 3, x plus 4, without having to do the whole AC method. And then we said if this factor, that's things you multiply, times this factor 0, then either one or both of those factors has to be 0. And so we said either x plus 3 equals 0 or x plus 4 equals 0. And so now we're going to undo addition by subtraction. We get x equal negative 3. Undo addition by subtraction, get x equal negative 4. And so we have the two solutions to the quadratic. They're also called the x-intercepts of the quadratic. So it would be like that's at x is negative 3 and that's at x is negative 4, where those hit. We also call them the roots of the quadratic. Since they're the values of x that make y equal 0, we also call them the zeros of the quadratic. So the x-intercepts, the solutions, the roots, the zeros, they all mean the same thing. Okay? So the solutions were x equal negative 3, x equal negative 4, which you know is wrong. Why is that wrong? Well, it's wrong because it's in a solution set bracket. These little things are solution set brackets. And when we put answers in solution set brackets, they must be written from least to greatest. And negative 4 is less than negative 3. So a reminder, there's a mistake right there that circled through my negative sign. Uh, a reminder that when you write answers in a solution set to put them least to greatest. Any questions on that one? Okay. All right. We're going to leave the next one for you to solve on your own, and we're going to solve using the quadratic formula here for number 9. We will solve the quadratic formula all the way down on paper, and then we'll also show you how to use the graphing calculator to solve with the quadratic formula. The quadratic formula is in the Algebra 1 text on page 221. This little part that may look a little bit unclear to you is a minus 4 times A times C. That's that little smudgy looking part, minus 4AC. Now, the A of the quadratic is 3, the B of the quadratic is 4, and the C of the quadratic is negative 6. We can solve a quadratic by plugging the A, B, and C into that quadratic formula. And so we're going to have x is equal to, the way we read that negative sign right there is the opposite of B, which means we change the sign of B. It was a positive 4, so we make it a negative 4. Plus or minus. The reason that comes in is when you take the square root of something to solve, somewhere in that solving process, see, we would get rid of the square with the square root. That's how it enters into the formula. When you take the square root to solve with, you have plus or minus square root. Now, it teaches you that in the algebra book on page 26, example 5. So we have the opposite of B. We're following the formula here. Plus or minus whatever B is squared. B is a 4 square. Now, don't forget, if that's a negative 4, you have to put it in parentheses squared. That's on page 170 of the algebra book. We talked about if you don't lock that negative onto it in a parenthesis, it will separate itself as a negative 1 times before it gets squared, and it won't get squared with the exponent. And so we're going to have whatever B is squared minus 4 times my A of 3. That's an A positive 3 times my C. Now we got to carry that minus as a sign, so my C is negative 6. So the opposite of B plus or minus the square root of B squared minus 4AC all over 2 times the A value of 3. So again, we're plugging the A, B, and C that we identified into the A, B, and C of the formula and coming up with this equation. Now, when we go to solve, the first move, we can actually do 3 things. We can do the exponent. This is if we're going to show our work on paper. And then we can do this multiplication. And we can do that multiplication all in the first step because none of those 3 things are going to have effect on the other one. We'll look at doing this on the graphing calculator in a moment. So we will have x is equal to negative 4 plus or minus the square root of 4 squared is 16. And then we're going to deal with this. Now watch when we do this. This is important. We have to identify the signs. And the way I teach it in Algebra 1 is we carry the minus as a sign. Excuse me. So we're going to call that a negative 4 because we're going to carry the minus as a sign. We call this a positive 3. And that's a negative 6. On page 18 of the algebra text, we have sign rules, and when you look at multiplication and division, it says when you multiply or divide with an even number of negatives, the answer is positive. When you multiply or divide with an odd number of negatives, the answer is negative. Now we have 2 negatives. That's an even number of negatives. That means the answer is going to be positive, so we put a plus. And we have 4 times 3. 4 times 3 is 12 times 6 is 72. All over 2 times 3 is 6. So we did 3 chunks. Now, we're going to finish up under that square root. And so we will have x is equal to negative 4 plus or minus the square root of 16 plus 72 is 88. All over 6. Let's see if we got that. Okay. Now, at this time, we take the square root, and you may look at the square root of 88 and you say, well, there's not a perfect square root of 88. Now, we haven't gotten to this in the geometry book yet, but in the Algebra 1 textbook on pages 15 and 16, this is the first time that it's exposed to you there. That's on page 15, 16 of chapter 1. We go over this again in chapter 9 on about page 248. So this is on page 15 to 16 in chapter 1. It shows up again in chapter 9 of the Algebra 1 text on page 248. And what I'm talking about is breaking down a radical like square root of 88 and putting it in simplest form. Now, to do that, you do the prime factorization. You would take 88 divided by 2 is 44, divided by 2 is 11, and 11 is prime. And so we would rewrite it as the product of its primes, 2 times 2 times 11. We circle sets of 2 for square root, sets of 3 for cube root, sets of 4 for fourth root, etc. From each set, we bring that number out. I'm quoting page 15. What did not get circled in a set goes back in. If there was more than one outside, we'd have to multiply those. If there's more than one inside, we would have to multiply those. So that square root of 88, that's our next move, simplifies into 2 square root 11. That's not the final answer. That's just what the square root of 88 turns into. Okay? Now I'm going to clean up some of these page number things over here so we can finish this. In fact, I'm just going to get rid of a lot of that stuff so I can finish this. Let me just clean up that whole side over there. Let me leave that radical stuff. Okay? So we're going to go from here to x is equal to negative 4. Now, we just dealt with that square root, and so now is where the plus or minus comes in. And so we're going to have negative 4 plus or minus 2 square root 11 over 6. So it's time to mess with the plus minus. So we have x is equal to negative 4 plus 2 square root 11 over 6, or x is equal to negative 4 minus. Let me make myself some space here. Problem's taking a little bit of room. That didn't stay going away, did it? Or x is equal to negative 4, now to the minus 2 square root 11 over 6. it happens that the 4, the 2, and the 6 have a common factor of 2, and so we could reduce by a factor of 2, and we would have here negative 2 plus square root 11 over 3. On the bottom, negative 2 minus square root 11 over 3. And those are our two solutions. So we brought back a lot of algebra on that particular problem. Okay. And we'll let you play with that last one on your own. There are some discovery learning things. Again, we want you to get a protractor, a ruler. We want you to measure precisely. If you don't know exactly what you're supposed to write in the blank, then you should know that that's the next lesson, so you can go over there and take a peek at the rules in the next lesson, just in case you didn't measure exactly, and you can find those answers. And so then that would bring us to Unit 4.1, Properties of Parallelograms, which we will begin recording in a moment.